Hi everyone. This is a video tutorial on first order ray tracing of a doublet lens using the YU tabular method. In the next video, we'll see how to use the ABCD matrix. So here I have taken this example from a Coursera course. We have given a doublet lens. So the radius of curvature of the first surface, of the second surface, and the third surface, the plane is the flat surface, and also the reflex of induction, like of both the surfaces are given. And then you have kept an object at a distance of like 300 mm, and the object has height of like 20 mm. And the question we need to find is we need to find the distance at which you get the image, right? So this is the quantity we need to find, L dash or X, right? So this we need to find. This is our problem statement. So let's see how to solve this. So let's consider first we need to in order to find L dash, first we need to populate all the values in the table. Then figuring out L dash, it's quite straightforward. So let's go through each of the variables like one by one. So the first thing is called the curvature, which is nothing but the 1 by the radius of curvature, right? Now, let's say if you look at the zeroth surface, which is nothing but the object plane, there is no curvature, right? Because there is only object, there is no like a surface, it's just like empty air. Now, if you go to the first surface, which is like the front surface of this lens, then the curvature is actually 1 by radius, so it is 1 by 50, which is like 0.02. And for the second surface, it is actually again 1 by 50, but it's in the opposite direction, right? So it is minus 0.02. And for the third surface, since it's like a flat surface, the curvature is like 0. And for the fourth surface, of course, there is like nothing because it's just like the plane at which the image is formed. So second, we have to define the refraction of index. Um, so for example, and this is the refraction surface after the surface. For example, if 0 is this is the surface, what is the index of refraction after this surface? So this is the area. So here after the 0th surface we have R, which is nothing but like the index of refraction is like 1. And now when we come to the first surface, the index of refraction, um, just a second. So when we come to the R, like the index of refraction, here it is like 1.5, so we enter 1.5. And then for the second surface, so this is the second surface, the index of refraction is like 1.6, so we write 1.6. And for the third surface, this is the third one, the index of refraction is actually this one, which is like 1. Okay. So we have entered both the C and N. So now we need to calculate the power, right? So power is nothing but the 1 by focal length. So, but in this video, like these are all the only data which is given in the problem set. We don't have any data about what is the power. So you might want to stop here and like Google like how to find the power or how to get the formula or something. And after some research, if you found out, it is good. If not, like here is the answer. So power is actually the curvature into the difference of index of refraction, right? And for the zero surface, there is like nothing because there is like no curvature or it's meaningless. And for the first surface, the power is, let's say, like is 0.02 into 1.5 minus 1, so which is like zero point 0.5. So zero point 0.5 into 0.02, it is actually 0.01, right? And then similarly we do for second and third surface. We just take the difference in index of refraction multiplied by the curvature. We get the value. And for the flatter surface, since it is like flat, the curvature is 0. The power is also 0. But even the power is 0, there will be bending because there is a difference in index refraction index, right? Like between this medium and this medium. And for the fourth, it's not defined. Second, so now we can replace this diagram, the doublet lens, with a simple paraxial thin lens approximation. So here it is a thin lens with no thickness, just the power is given. Um, and now we'll enter the decay. The decay is nothing but the, um, the distance, right? So the distance from one surface to the vertices of the next surface. So for the zero, it is like 300, which is the distance at which the object is placed, and next is 10. This is the value from the first surface to the second, and from second surface to third is 2. But then now we need to find, as I told earlier, the distance between the third surface to the image. Okay, so so this is the quantity which we need to find. So now let us consider a single ray through the system. So far all these four variables define the system which we are working, which means the lens. And now we are going to define the ray which we are going to shoot. And somehow if we are able to get the values of these values, we'll be able to get the x. So as we solve along, it will be more clearer. So just stay with the video, right? So now let us shoot a ray through from the object to the first plane, and let's choose. And so it's our decision. We can choose whatever ray we want, and we have decided the ray the height will be like 0, and the angle in radians will be like 0.01, right? So this is the value which we have chosen. So now we need to find this value. So we need to find the height at the surface, first surface. So which is nothing but we need to find what is this height. Let me choose different color. Okay. So we need to find this height, right? We need to find this height at the surface. So that's what. Uh, so we need to find this variable. So how to find this? You might, if you are taking the Coursera course, you might want to stop here and look at your notes or something. Uh, so this is more like a revision tutorial. So yeah. So this is a formula, which is a very basic formula like a trigonometry. It is nothing but what it tells is the height at let's say the next surface is equal to the height at the previous surface, like the starting point, and the extra distance, right? The extra distance in a paraxial line, it is nothing but the angle u multiplied with this distance d, right? So you multiply u into d, you will get this distance, and then plus you add the initial distance. So it is a very simple trigonometry. I hope it's clearer to you how we got this formula. So now if you substitute for the first surface, which is like the initial height, plus the angle is like 0.01 into the distance 300, you will get 3. And now we need to find the exit angle. So the exit angle is like the so for example here if you draw the optical axis, not able to draw straight. So what is this angle? So this is the exit angle. I mean I didn't draw it straight, but it will be like straight, right? So it should be straight. I'm not able to draw it here, but I hope you understand. So then what is the so then we have this formula. It is very similar to actually it's actually Snell's law, where you have the index of refraction after the surface exiting the surface, and exiting the angle is equal to incident index of refraction into incident angle. But the difference is this term, where you subtract by the power of the lens, since the lens has the power, and height, because that gives additional bending, and it's not just a simple surface. That's why it's called power. So this is the extra term. So you could remember this by remembering Snell's law, right? So now if you substitute all the values, for example, for the first surface for this one, what is the incident, reflection of index? It is like 1, and then the incident angle is like 0.01. So this is the 0.01 into this refraction index minus the height of the ray, which is like 3, which we just now calculated, into the power of the lens, which is like 0.01, divided by the index of reflection of the after the exiting the angle, right? So what is this index, which is like 1.5. So we just divide by 1.5, and we get this value. You could do the calculations just to get a feel of this problem. So now we have to just repeat these two formulas for both the second and third surface. Okay? That's it. So I will just you could stop the video and you know go through these calculations, but I'm not going to explain. It's just simple substitution, what I said for the first surface and second surface. Yes. So now we have done for all the surfaces for let's say 0, 1, 2, 3, and and the thing is the fourth surface is the plane at which the image is formed, right? So on this plane, the height of the image will be like 0, right? And using this 0, and also we could write um, the 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 height at the new surface, which is the fourth one, in terms of the third surface, like this, right? If you write like this, then there is a way to solve for x, and if you solve, it's like very straightforward. It's approximately equal to 200 mm, right? So mm, think that's all for the video. I hope I mean, it's like useful to all of you. And let me know like if you have any feedback or suggestions to the system. I would love to hear like what you think. Thank you for your time. Have a nice